Yes, we recently ordered some xenon bulbs from Tony Greer, Lubbock, Texas, Special Effects Neon. He sent me this little note, and when I told him I wanted to make a sort of a channelized discharge for on the xenon, because I was investigating radio waves coming from plasma discharges, he recommended that I have them made at a higher pressure of 40 torr, and this is where he says, thanks for your order. I adjusted the pressure in these to 40 torr because they seem to work better at that pressure. Okay, all my other bulbs I think were made at 10 torr, and at 10 torr you get a more of a full channel discharge, and that's from a 30 milliamp neon sine transformer. And we'll shut that off and quickly show the difference on the xenon bulb filled at 40 torr. If we can remember how these things work. There we are. Safety first, as they say. I don't know. Got a shock from an ungrounded transformer formerly. Let's get that thing out of there before it gets broke. I'll shut it off again. Yeah, I can feel a little bit of heat build up on that bulb. Turn that back on again. And there's the more finely lined xenon bulb discharge. Okay, originally then we wanted to compare that discharge. There's another bulb underneath it. Same 40 torr pressure. And originally we wanted to compare that discharge to an alternator frequency resonant circuit discharge. But what we were looking at in the first place was what makes the radio waves. So here we can pretty much settle that. In the following demonstration we have a 20,000 hertz high voltage supply, European. The input specs are 220 volts, 20 milliamps, and we're running it at American, USA 120, and we're probably only getting 10 milliamps on the secondary. And we got two bulbs going through there. On the left we have a xenon. Get a stick here. On the left there we have a xenon, and on the right we have a krypton. We'll turn that on, and we can see that's a complete circuit there. At first, when I started playing with these things, I thought there might be an asymmetry, but in fact there is an asymmetry involved when you series those two discharges. Now what we're going to do then, so we got some bulbs underneath there. Those are some neon bulbs. As you'll see, no radio waves coming from that xenon discharge. Well, the bulbs might be lighting up there, right? But the xenon discharge has a marked channelized effect at 40 torr, 20,000 hertz transformer, and the xenon is at 10 torr, so it's more of a full channel. So we're going back now and we're looking at this, and we've been playing with experiments where we disrupt the midpoint, and we've got this. In this experiment we have a glass midpoint interruption for a small capacity. Now we've taken one out of the circuit completely, and when we did that, going to the discharge, the wireless power to the three neon bulbs around it happened. So this makes this kind of thing ideal for plant germination experiments, and on and on and on, whatever you want. You know, if you want to have plates around a treadmill device and have an electric fields doing that to your body while you're exercising, well, that'll be up to you, I suppose. Now then, we're going back here and replacing this side of the circuit. It's kind of hard to do this sometimes. Okay, I don't know if you can capture that. You can see that, the camera. There's my body path. I'm trying to get back over here and get that middle on there and make the path to there. Okay, now we've got the continued path then. And on that continued path, we'll have to get back and show where the break of the path is and what that is. Up there we've got some glass, some colored glass cut in pyramidal shapes and all that. Ain't no gems or nothing, I don't imagine. And we're using the capacity of the glass from the tip there down to a holder to a plate, and then to the plate there goes the krypton bulb. Now to final out here then, back up and show this remarkable demonstration similar to a Tesla coil secondary coming from one of these solid state transformers from the violet ray, you know? That's what it is. It's that damn violet ray, I'm telling you. Where are we at here there? There's that violet ray. Okay. Those bulbs are underneath there. Back out. We'll try to show periphery effects. It goes out in space, see? Wouldn't you want your germination seed tray doing this to a neon bulb? No, we don't really know whether the krypton does any better. It may be the case that the krypton's actually better for grounded effects. It's got a lower striking voltage. And of course there. Oh, and so we showed that, and we should show one more thing before we quit. And to do that, we have to connect the bulbs at the endings. We'll shut that off real quick. Wrong one. Wrong one, Doctor, wrong way. Indeed. And we still got the other transformer working. It's confusing. Gotta find a wire real quick. Unpaste this. Well, we can just show it from connection ends. And I like the wire. Okay then, now we got bodily influence on the possibilities. I'm looking at the camera. Where's the bars? I'll turn that on again. Now note here that when the krypton goes first, it won't hardly ionize the second bulb, but when the xenon goes first, it will. And discharge goes through the left hand to ground. Same thing on the other side. And here too. Under special conditions, placement of hands, you can get both discharges to work. I don't remember how that worked. There we are, see that? Your hands have to be in a certain spot on the tube for the second discharge to issue. And I don't know if we can show it on that side too. I was thinking there's differences in power out that. Yep. Seems to work on this side. Don't want to work like it does on that side. So we got to look at these things and say maybe there's a hotter side than the other. That would seem to be the case there. Yeah, it started sparking. Now, if you barely touch your fingers, you can feel the bulb vibrating. There's some noises sometimes too. Okay, that's it. Turn them off. Sayonara.